appreciate it. And thanks for joining us here today. Yeah, going to talk about what I think is one of the dirty little problems that we have in our industry. That those outside of our industry would assume that we would have solved this a long time ago, in terms of being able to control devices and services anywhere they are. But those of us who are in the business know that this is an ongoing problem. So, just going to give you a very high level overview of an approach to solve this in an open standards, open source way, which we think is the only way to really solve for the control plane challenge that we've got. So, the reality in our business today is, and it's almost become something that we don't talk about that much anymore because it's just assumed, right? That media in the cloud is a reality. That there's been more and more things moving to the cloud. I can tell you, we've been moving products almost monthly into the cloud. So that's one of the realities. As you move things into the cloud, you almost inevitably end up with more vendors than you probably had doing things on-prem, particularly if they're embracing things like microservice-based architectures where you break things down into smaller chunks. You inevitably end up with more vendors. When you get more vendors, you have more challenge in terms of integrating those together. So another reality that we have to face. The final thing is, as we move from on-prem environments to cloud environments, uh, you no longer, air gapping to the internet is no longer an option. So you have the risk of having your content and the control of that content sitting in the cloud. And so security needs to be a priority, and you need to do some things that you never had to do before in an on-prem environment. So we looked at that kind of being the reality. We said, okay, really what we need to do is to be able to secure being number one. Because if we don't have security around this, this is not usable practically. So to be able to secure, connect, and control multi-vendor ecosystem of media processing services, microservices, and I should add probably devices as well. The idea here is, ideally, I shouldn't have to care if devices or services are on-prem, in a public cloud, on a private cloud. Shouldn't make any difference at all to me in terms of being able to control them in a perfect world. So that's really where we want to get with all of this. So how do we do that? It's actually fairly straightforward at a fundamental level. Is let's have a consistent way of having all of these services, microservices, devices, have them all be controlled and connected in a consistent way. Have a single protocol that would be able to do all that. So that's the kind of the problem statement. Um, and so, as we looked at, what do we need to do? Well, I think, the most demanding scenario that you've got is live video processing, live production. Probably the most demanding thing that you've got. So if we can address the that issue, that scenario, we can we can handle probably any other um, environment that we might have to deal with. Excuse me. I already said, multi-vendor simultaneously is obviously very important. Um, has to be able to scale. When you think about controlling media services, particularly for a very large media company, a very large production, the number of messages that are flowing through the ether to control everything that's going on can be absolutely overwhelming. It needs to be able to scale for that. Also, it's completely unrealistic to take down your production or your media operation in the middle of something to add a device, right? Or to add a service to it. So it needs to truly be plug and play while operational. Middle of a production, you need to be able to add services, add devices, and just detect them, pick it up, and have it just run. And of course, I keep harping on security. You're gonna hear security more than once in here, but it's critically important. So what we call this is Katina, and you can thank us for not adding not adding yet another three-letter acronym to the lexicon of media. We decided rather than using an acronym, we would actually give this a name. And Katina is an actual word that means a connected series of related things. And I don't know why it says text box with image, but uh, little technical glitch there. So, Katina is based on something that's well proven in our industry. If you're familiar with Open Gear, this is something that's been around for about 15 years now. It was originally designed to make it easy to connect together solutions, devices from a wide array of vendors in an open and standardized type of way. Um, it was not really a true standard, and it isn't a true standard now. Um, but it was created by Ross Video, and we like to say it was controlled very benevolently. It was very, it's got open in its name, so it was as open as possible. Try to get as many vendors, as many products to use it as possible, and it's right now. I think there's about 150-ish Open Gear partners, so it's succeeded very nicely with that. However, keep in mind this was designed 15, 16 years ago. None of us had even a thought of running things in the cloud at that point, and all the scale, security, and other issues that come along with that. So it needed a kind of a refresh to be able to deal with that. And so we said, okay, why don't we base what we know works well, and that 150 partners are already familiar with. Let's base it on that, but then add what we know is needed for today's operations that go beyond on-prem. Um, and the other thing that we decided early on at Ross Video is, this is not our core business. Maintaining this Open Gear partner network is something that we do, but as you move into the cloud and move potentially beyond the 150 partners to maybe thousands of partners, this is not something that, first of all, Ross Video had an interest in doing, and we didn't think we were the right people to do it anyway. We thought this makes a whole lot more sense to have a Switzerland of organizations like SMPTE, an industry organization to run this, administer it, um, and make it a full standard rather than a de facto standard, which is kind of what Open Gear and the Open Gear protocol has been in the past. So, and then in addition to making this an open standard, we thought if you want to remove barriers to adoption, let's open source it. So put it out on GitHub, make it available for anybody who wants to go and access it and use it for free. Um, there shouldn't be any barriers to adoption of this. So this is an open standard, open sourced, as easy to use as possible. So that's what we've done. We've taken this and offered this up to SMPTE. Um, this is just kind of an outline of the types of things that it includes. So it allows you to if I'm a service or I'm a device, it allows me to register myself and say, "Hi there, I'm device A, and here's all the things I can do. Here's all the different ways you can control me." So it includes that, and then of course the ability to then go and give it commands, control it, get status messages to say, "Hey, I'm healthy. Hey, I just executed that last command just fine," or "No, I didn't." Um, and of course comes back to security, once again, and I'm going to dive more into that. One important note here though is, and people tend to sometimes get mixed up on this. They'll say, well, Katina is orchestration. It's an orchestration engine. It's not. It just facilitates easier orchestration of media services. So it's not an orchestrator itself at all. But hopefully it makes all that much easier for people who are doing that. Um, so I mentioned scale again, that this can scale up to very large sizes. So again, you think about microservices that have, they do maybe one thing, right? And only one thing. Um, that you have to be able to deal with a service of that size, which is very small, very simple, or even a device that's very small and very simple and does a very simple task, to something that's incredibly complex and could have thousands of parameters for controlling it. So it's got to scale from very small to very large and work for both of those. Um, Obviously, working with cloud environments in mind is key, as well as on-prem. And really, the reality is where we are as a business right now is hybrid environments, where some things are on-prem, some things are in the cloud. They could be on multiple different clouds. That's where we are, I think, for the foreseeable future. And so it has to work in that type of an environment. So at the heart of Katina, um, the model is all built around a device. So, and when we talk about a device, um, we've got a few pictures here showing the types of things that it could be. It could be something from an incredibly complex switcher, audio mixer, uh, multi-viewer. It could be anything, all the way down to something very, very small, either a very small hardware device like we see here, um, or it could even be a device that doesn't you wouldn't think of as a media device, a robot. The robot doesn't directly touch media, but it's involved in media production. So it can even control robots. We like to say, it can control your lighting grid. Um, it could control your coffee maker if you wanted it to do that. It doesn't care. As long as you have a device, if a device is Katina compliant and can describe its capabilities uh, using Katina's protocol, it can be controlled. So I'm actually going to skip over that one. So like I said, at the heart is a device description here. So, um, and the idea is that if a device gets a query to say, hey, who are you? What can you do? It has a standardized structure in which to describe all of that, so that it can be controlled. Um, just kind of restating here that it does this. We do need to be able to add devices at will at any time with no notice, and be able to recognize them and control them very quickly. Um, when we deal with complex devices like we were talking about, there can be some very complex devices controlled by Katina. One thing that's really nice is that you can break devices into sub-devices. And so you have a bit of a hierarchical tree structure like this, where you've got a big device and then some sub-devices below it, and each one of those can have its own unique set of parameters, commands, menus for control of them. Um, you might ask what a parameter is. It's basically a value, or in more cases, a set of values that represent a variety of items within the device. So they can be, kind of what you would suspect. A parameter can be an integer, a float, a string. It could even be an array or a structure of some kind. It can be constrained with a certain range of values or an enumerated list of values. Um, and one of the things that we think is pretty cool here, that again makes orchestrators' lives easier, and any devices that deal with Katina easier, is we provide a UI widget hint, and basically says this device with the types of parameters that it's got can best be represented in a UI by a radio button or by a slider or whatever type of control you want. So you can give a hint. So if somebody wants to build a UI around this, they don't have to guess and say, well, let's try this type of control. Let's try this type of control. We have a list of, we have recommendations already there for them to say, here's probably the way you want to represent this in a UI. Um, you probably saw on the slide a couple back there, we had parameters there, and I mentioned each parameter has a value or a set of values, um, not to be confused with commands, which commands are used for actually executing and controlling the device or the service. So, and again, each command could be controlling. It's got 0 to many. I think it's really 1 to many, because I'm not sure why you would have 0 parameters on a command. Go. Okay. That would never. Okay. So you could have something with no parameters, but in a lot of cases you would have one. Um, and we do differentiate each one of these parameters and commands with what we call an OID, an object identifier. So they are uniquely referenced, uniquely tracked, so that we can keep them all separate it out, track their status individually. Um, yeah, it makes it fairly straightforward. So, an example, rather than kind of speaking in abstract terms here, let's say we have a service and all it can do is just play a channel of video. That's it. So, in the Katina realm, it's important that can be discovered and can respond to queries about what it can do. So, this type of service, um, we may be able to get some kind of parameters on the state of playout. Am I playing? Am I not playing? What are the audio meters reading at this particular point? How does sync look? That sort of thing. Um, then in terms of control, we have commands that can actually manipulate it. So we could say, I want to play. Well, what speed do you want to play it at? You want to play it at 1 time speed, 2 times speed, half time speed, whatever. Other things like this. So those are examples of how parameters and commands might work with a Katina device. Another important concept with Katina is that we need to be able to talk to these devices asynchronously. Um, so again, it's important that when you're dealing with a device that is very complex and has a large amount of parameters and data that might be flowing back and forth to it, that we don't bog down the network and that we're able to deal with a lot of these devices. The classic example that we give is like an audio meter. And if we're getting values from an audio meter, many times a second, and you've got uh, thousands of audio meters in your facility, you can see how you could easily bog down the network if you didn't kind of control the flow of that. So we do have that in mind with the whole Katina architecture here. I promise to come back a little bit on security. Not the most exciting topic, but incredibly critical if you're going to be controlling services and devices in the cloud in particular. Katina follows industry standard zero trust tenets from I probably have it listed on the next slide, but from NIST, who has defined zero trust. Um, so yeah, the communications need to be confidential, maintain their integrity, and be fully auditable and available. So, um, one thing we really like is that AMWA did some really good work on this in IS-10, in their implementation specification 10, which follows the NIST zero trust tenets and OAuth 2, but constrains them in a what we think is an intelligent way for media. And so, we will we'll be pointing directly to IS-10 in the Katina standard when it comes to security. So yeah, there's the NIST document that defines zero trust, which is an important part of all of this. Again, we see a lot of people requiring or at least recommending zero trust when we're dealing with security over on the cloud. Um, and like I said, why reinvent something if it's already been done well for our industry? And we think it has been with IS-10 from AMWA. So again, we'll be pointing directly to IS-10 in the area of security. All right. Actually, I'm gonna skip past a lot of this and just while we're on the topic of IS-10, just kind of talk about again the underlying technology behind IS-10 is OAuth 2. We really like it. Um, One thing that we have kind of looked at is again in the interest of scalability and not wanting to bog down a network with security. Um, that we don't just say just go ahead and do zero trust and everything's going to be good. That's not going to work. Particularly if you say if every time you're polling a device you have to reestablish its credentials. That would be a horrible way to deal with security. So it's zero trust with some media asterisks, I guess you might want to say, in terms of how we deal with it. Um, internally, in terms of access scopes, this is another important part of security. Um, we're guilty of actually creating an acronym here, but it's a catchy one. Gusto, we're talking about the Grand Unified Scopes Theory optimized for media production. So, what is this? And this is a great way of dealing with the reality that we have in terms of the types of people who would be accessing devices using Katina. So, you can we're trying to keep the number of roles fairly constrained. You could go crazy with this, but let's say a great example for a news operation would be you could have a journalist, you could have a producer, you could have a TD, you could have somebody from security operations in there. Each one of those roles has certain things they should be allowed to do, certain things they should not be allowed to do. Um, but it makes it so much easier if you can fit somebody into a role. So an example here would be we've got a user named Colleen, and she could have producer rights for a particular thing uh, on a project, let's say in New York City, but she could also have journalist rights. So one person can actually fulfill multiple roles, as we know. That's kind of the reality in operations today. That today I'm a journalist, tomorrow I'm a producer, I'm on the camera the next day, whatever. And we can deal with that with these access scopes. So basically, what we do um, is say with the parameters and commands that we talked about earlier, each one of those is assigned a what we call a risk level. Um, and uh, and we'll say, okay, this particular thing could take us off air. That would be a high risk level, or it's fairly innocuous if somebody happened to hit this item without the proper authorization. So we have all those types of levels that we can assign people to. So again, another example here where I've got a producer in New York on a particular service. Let's say this is a service that controls a certain server channel, so we can give them rights to play that channel out. And maybe there's another service that does a 90-degree rotation because I get some of my video from iPhones and I want to rotate it around 90 degrees. Okay, we can provide that, and you can limit their access to only being able to do that if that's what you want to do. In terms of transport, uh, in uh, in Katina, we favor something called gRPC, which is another sort of industry standard. Not exactly a standard, but it's an accepted practice. This is Google's remote procedure call, and we use that for serializing and deserializing the messages. And so we do have a strong preference for gRPC in the spec. We do use protobufs as well within Katina. There's some debate as to how much of this will actually be prescribed in terms of gRPC. Um, we are not at this point making it an absolute requirement. It's more of a preference. Yeah, if you want to use something other than gRPC, we've kind of left the door open at this point to that. We're debating that. Um, let's see. Orchestration. I mentioned earlier that Katina itself is not an orchestration system. It just makes orchestration easier. It's a facilitator for orchestration. But orchestration in itself can be a very overloaded term. So, what do we mean by orchestration? Basically, it's everything you need to do to prepare a device or a service to be used in normal operation. So, if I stand up a service, what do I need to do to make that ready to actually go to air and be used? Um, and that's really what we mean by this. Also, inherent in orchestration is knowing the status of an application or a service that's being used in there. Um, and then to be able to recover if there are problems with that. Um, our attitude there is there are plenty of existing orchestration systems out there that we do not need to be prescriptive in terms of that. Use the one that you like. And again, Katina just makes its job much, much easier. I touched a little bit earlier on this. The UI menu hints we think is huge for people wanting to build UIs in a Katina environment. The UI hint I think is great, and these are some of the examples I gave before of saying, in order to control this parameter, we think a slider would be most appropriate. Not to say you couldn't use something else, but it really speeds up UI development. If you just take the hints that we give, they're probably going to work pretty well for the different controls that we have. And so you can create a UI very, very quickly using that. Um, it does not fully define your UI, of course. It just makes it easier to stand up the UI. Um, whoops, I skipped over one there. Um, and then finally, in terms of discovery, um, yeah, this is also something that we think AMWA's done a really nice job of between with ISO 4 and then with ISO 5 as well as a partner to that. Um, we're a great believer in what's been done there, and our plan in terms of discovery is to point to as much of the good work as we can that's been done within AMWA in terms of discovery. So just to kind of wrap this up, we think, and it's been validated through a lot of conversations that we have had with people that this solves one of the biggest gaps we've got in our industry, and one of the biggest problems that we've got is the fact that we do not have a standardized way to control media devices and services. Right now, it's a mess of protocols and APIs that you've got to use to do this, and so and it's really untenable going forward. The industry needs this badly. We've been socializing the idea of Katina for quite a while now. I have yet to have one person say, oh, no, that problem's already solved, or that problem doesn't really exist. Everybody, it's really been unanimous of like, okay, yes, we do need a solution here. It's great to see somebody's working on this. We're working on Katina in the within SMPTE's RIS OSA structure. So if you're interested in learning more about it or getting involved, staying up to date on what we're doing, um, join SMPTE. If you're not a SMPTE member, join the SMPTE's RIS, which is the Rapid Industry Solutions Group, which is intended to develop these things very quickly. We've been working on Katina in SMPTE's RIS OSA group for about a year now, and we're at the point already where we're transitioning the initial interface document and the various files needed to do that over to SMPTE to their standards group. So we are rapid. We take that seriously. I think I finished with about a minute left,
You did
Wes.
very good. All right. Anybody have any questions?